Good afternoon, everybody, and welcome to today's Intel webinar, New Microarchitectures, Develop Performance Apps for Intel Xeon Phi and Haswell platform. My name is Kevin Askew. I'm Director of Sales here at TechXtend, and today's agenda will include a brief intro on TechXtend, followed by today's webinar, hosted by Ashish Gupta, Marketing Manager for the Software and Services Group at Intel Corp. We'll also have a question and answers period and a summary. TechXtend, formerly Programmer's Paradise, has a 30-year history of being North America's leading provider of software developer and database tools. As TechXtend, we also focus on virtualization and cloud computing, storage and infrastructure management, and business intelligence and information management. TechXtend is a evaluated reseller of developer and infrastructure tools. We can be found on the web at www.techextend.com, and Intel's solutions fall under our ALM Worldview ecosystem. We are an elite Intel reseller partner in North America. Under that ALM Worldview, we provide industry-leading tools for your end-to-end development needs, including defining, designing, developing, testing, deploying, and managing. I will now turn things over to Ashish for today's webinar. Ashish?
Thank you, Kevin. Good afternoon, everyone. And thanks for joining. My name is Ashish Gupta. I'm with Intel. I'm in marketing with Intel. I've been fortunate enough to be with Intel for, over 18 years now. And I've spent the last few years in Intel's Software and Services Group working on our software products, which you'll see today. And a couple of things on the WebEx. You'll notice in the bottom left, there's a little button called Full Screen. If you click on that, you'll be able to see the slides, and it'll fill up your screen. And on the top right, there is a button called Q&A, and I'd encourage you guys to ask whatever questions you've got. And what we'll do is we'll pause in between sections, and we'll take a couple of Q&A, and then at the very end, we'll open it up for additional questions as well. Okay, so let's get started. Our agenda today is we're going to talk about how performance is delivered. Intel is known as a processor company, and even now people come to me and say, "What? You work at Intel Software?" My own family says, "Why do you work at Intel Software? Intel's a hardware company." And I have to explain to them, look, in order to make hardware, you've got to make software. And I'm going to explain to you how performance is delivered. I'm going to show you a processor roadmap. And the point I'm going to try and drive home is there's a lot of goodness we're going to provide in our CPUs, which you as application developers need to know about in order to take advantage of. The next section is about using Intel software tools. So knowing what's in your CPU is step one. Actually using it is step two. And step two, we're going to talk about 3 steps to using Intel software tools. The group I'm in has a legacy of over 25 years of creating software tools. We have over 1,000 engineers, right? And there's a lot of goodness over here, but a lot of them are quite complicated. So we're going to try and simplify a bit today and explain to you how to go about doing this. The third section is Xeon Phi. Xeon Phi is very exciting. This is our first coprocessor that we started shipping in November last year. It starts at 61 cores, right, which, as you can imagine, is a pretty beefy machine. And people call it a supercomputer on a chip because a single Xeon Phi is capable of over 1 teraflop floating point operations per second, right? So we're going to talk about Xeon Phi a bit. And then we'll go into some helpful links and some resources, and then you can get that slide, the last slide from TechXtend, which has a listing of white papers, case studies, product briefs, videos, testimonials, the kinds of things you would actually find useful when you are ready to make a purchase. Okay, so first things, Intel Software and Services Group, right? For those of you who haven't heard of us, we're quite large, even though Intel, of course, is much larger. We have about 14,000 employees now, and I think last year, SSG brought in about $2.4 billion in revenue. So it's a decent revenue for Intel. We're all over the place, over 35 different sites, and Wind River, McAfee, Havoc, Telmap, Nordic Edge, there's a whole bunch of smaller companies that are also part of SSG. The group I'm in is called the Developer Products Division, and we focus on tools. We make compilers, libraries, analysis tools, et cetera, right? And we're going to talk about that today. Okay, So let's take a look at powerful Intel CPU capabilities. It used to be, if you guys remember a few years ago, it was all about gigahertz. So Intel would come up with a 2.2 gigahertz processor, our competition would come up with a 2.1 gigahertz processor, right? And then we would come out 2.3 gigahertz processor, and it was just kind of leapfrogging each other. Well, past 4 gigahertz, what we found was the silicon got so hot that the cooling required to keep it from melting became impractical, right? So a few years ago, Intel made the shift where gigahertz was no longer the primary way we would deliver performance, but we would deliver it the other ways like onboard cache memory, hyper-threading technology, multi-core, et cetera. So on the slide on your screen now, what you're seeing is the different brands on the top. So you see Pentium, Celeron, Core, i3, i5, i7, Xeon, all the way to Xeon Phi. And then you see a bunch of CPU features on there. Sandy Bridge and Ivy Bridge is our architecture name, and it goes across the different badges. But the features within each brand are quite similar, right? And obviously, the bigger the process, the more expensive it is, the more features or the more rich it is. But what I've done is I've color-coded each feature to indicate the interest to you as a programmer. In purple is gigahertz and turbo boost. And as a programmer, you have to do nothing additional to take advantage of this. This is just automatic, right? In light blue, you've got things like cache memory and hyper-threading. And chances are whatever tools you're using today, whether it's GCC or Visual Studio, chances are you're probably taking advantage of most of the features that these features provide, most of the benefit these features provide. In dark blue are features like multitasking, right? So this is multi-core, quick sync video and processor graphics. We've got SSE instructions in our CPUs, including AVX. AVX stands for Advanced Vector Extensions. We've got AES. AES, as you guys all know, is something we use every day. Or the WebEx right now is using it. Every time you log into your bank, you're using some sort of encryption. But what Intel did was we inserted some of the we reserved some transistors on our CPU for AES encryption. So as a developer, what you can do is you can offload your anytime you do encryption, rather than do it in software, you can do it in hardware on the CPU. PMU is an interesting feature. It's essentially a black box on the CPU, and it keeps track of everything coming in and out of the CPU, right? So if you were to monitor the PMU, you can look at counters, you can look at making decisions on, is my application waking up the CPU unnecessarily, which of course leads to lower battery life, right? A tremendous amount of information over here. And what we've done is our engineers for our tools sit together with the engineers for the CPUs, and we figure out, well, how do we go extract the benefit out of all of these features, and how do we expose them to you as a developer? Okay, so taking a look at our tick-tock model, right? So some of you may have heard of Intel's tick-tock model. What it essentially means is we alternate between shrinking our process geometries, right, where we go from 45 nanometer to 32 to 22, and then in 2014 to 14 nanometer. We do that 1 year, and then on the next year, we come up with a new microarchitecture. What that does is it allows us to reduce our risk, right, of basically we alternate, let's shrink down the process 1 year, and then we'll come up with a new microarchitecture. Well, 2013 is a very unique year. We typically only have one microarchitecture every 2 years, right, as this tick-tock model suggests. 2013, however, we've got both Xeon Phi and Haswell, and both of these architectures provide you with very different, pretty cool features. Haswell, for instance, takes what Sandy Bridge did, right, with AVX, and we have AVX2, Advanced Vector Extensions 2. We've got a feature in Haswell called SMA3, Fuse, Multiply, Add. We've got a feature called transactional memory, right? These are all really good things which you've got to take advantage of as a developer. And by using Intel's tools, what we're trying to do is give you a head up, right? So if you're going to use our tools, the release we shipped in November of last year already support both Haswell and Xeon Phi, right? So if you were to go out and buy Intel's Peril Studio, Cluster Studio XC tools and use them for optimizing application, when Haswell ships, and when it does ship, we typically ramp these CPUs quite rapidly. So we'll ship 100 million within a few quarters of launching. A customer who uses your application on the latest CPU already is able to take advantage of the latest features. Okay, so let's take a look at a picture of the die, right, of the actual CPU. Everybody knows Moore's law, right, which says we're going to double transistor count on our chipsets every 18 months. What most people don't realize is what is Intel doing with all these transistors, right? So the latest, this is the Core i5 or the i7. This one has 1.4 billion transistors, which is an incredible number of transistors. But what most people don't quite realize is, well, what are we doing? What are we using all these transistors for? And we've got, in this case, 40% of the die is used for processor graphics, right? And you can see there's 4 cores on this die. We've got a whole bunch of L3 cache. But what it's not showing you is the features we talked about, AVX2 or AVX, the PMU, right? All of these features are on the CPU. And my challenge is to go train developers and say, the CPU you've got is capable of doing amazing things, right? How do you extract all that benefit? So let's take a look at a little bit of history. We started Xeon with a single core, 2-thread, 64-bit processor. And over time, we've expanded the cores, right? So we've gone from 1 core to 2 cores to 4, and then Sandy Bridge is 8 cores and 16 threads. If you notice, SIMD width also increases, and SIMD width basically means you can execute a wider instruction with every clock cycle. So we're now at 256-bit with Sandy Bridge, and with Ivy Bridge. Haswell will also be 256-bit. The instruction set continues to increase as well. So we go from SSD2 to AVX. Haswell will have AVX2, FMA3, right? So as you can imagine, right, core counts, multiple threads, SIMD width, all of these are very important features to take advantage of. And the challenge to a developer is, as we have more cores, wider vectors, and co-processors on the right, how do you develop scalable software? On the co-processor side, we had a co-processor called Knight's Ferry. That was a code name. We started shipping that, I believe, in 2011. And we shipped it to 100 customers, and that was it. It was a beta run. And if it was successful, right, we said, well, we're going to go productize it. And we did with the name Xeon Phi. Xeon Phi launched in November and started shipping in volume this year. Xeon Phi, as I mentioned, has 61 cores, over 240 threads, and a SIMD width of 512-bit. Right, so this really is, there's a lot of processing power in this coprocessor, but it's applicable for certain workloads, not everything. And I'm going to talk about what workloads it's applicable for. Okay, so let me pause over here for a second and see if there's any questions coming in. And if you have a question, please type it in.
Doesn't seem to be any as of now, Ashish.
Okay, thank you, Natalie. All right, let's keep moving. So section 1 we covered was Intel CPU roadmap and how we're going to go deliver performance. The next part, we're going to talk about the tools that we've got. So you saw, as we're transitioning from multi-core to many-core, right, core count becomes very important for a developer to take advantage of. Wider vectors, as we go from 128-bit to 512 bits, right, again, this is something which in your application you've got to go figure out how to take advantage of. And then the other problem is scaling performance efficiently, right, as you go from serial to parallel using task and data or distributed, right, being able to efficiently use memory, the onboard cache, et cetera. So we have 2 products which we recommend people look at. The first one is for node-level parallelism, and it's called Parallel Studio XE. So if you have the application that runs on a single computer, we recommend taking a look at Parallel Studio XE. Cluster Studio XE is for applications that go across multiple machines, right? So if you're using MPI. And both of these products include industry-leading libraries, our compilers, some amazing programming models, which we'll talk about today, and some insightful analysis tools. And the reason Intel bundled them is we found a lot of customers are familiar with, let's say, an Intel compiler or VTune or our analysis tool, but they often don't see what else we've got in the suite, right? So bundling them in a suite, what we found is customers who are typically familiar with compilers say, hey, yeah, I'm going to go try this analysis tool, and they're often amazed at what they find. Okay, so the 3 steps. Step 1 is analyze your code, right? I've yet to talk to a customer, I've heard they exist, but I've yet to talk to one that doesn't have any source code already, right? So everybody I talk to always has source code. Sometimes it's 10, 15, 20 years old. And for them, they say, look, it's working. We want to get more performance out of it. What do we do? And the first thing we recommend you do is analyze your code. So Intel has 3 products here, Advisor, VTune, and Inspector. And the sole purpose of these tools is understand what's in your code. Step 2, once you find some areas that you can go modify, right, either by adding threading or adding parallelism, we've got some libraries and compilers which are sort of the low-hanging fruit, right? So we've got a couple of libraries. We've got Path Kernel Library and IPP, integrated performance primitives, and then we've got our compiler products. And then step 3 is, once you've done that and you want to get additional performance out of your application, that's when you start using our programming models. And we've got quite a few, right? We've got Silk Plus, threading building blocks, Intel MPI, OpenMP, OpenCL. Other vendors in this industry often give you, just one or 2 programming models. We realize one size does not fit all, right? Your problems are quite complex. So Intel has the luxury of providing you with several. So let's take a look at step 1. So step 1 is analyzing your code. If you're completely new to this, right, I would recommend starting with a product called Advisor, which is included in Parallel Studio XE. Advisor, I describe this as a bit like having an Intel engineer looking over your shoulder, someone who's an expert in adding parallelism. And what it does is allows you to analyze your code, helps you design any changes, help you tune it, help you check it. It basically allows you to model, one, identify where in your code you should consider adding parallelism, and also allows you to model the expected performance increase that you would get out of it, right? So if you find a piece of code where you're only getting like 3 or 4 or 5%, right, maybe you want to ignore that, but something else where you can get 2x, 3x the performance, maybe you want to focus in on that. And this is often the biggest challenge, right? You've got a application with 500,000, several million lines of code. Where do you even start? Advisor works with C, C++, Fortran, and C# code, and works on Linux and Windows. The next product is VTune. And VTune is a performance profiler. And what VTune will essentially do is help you figure out where your application is spending time, where it's wasting time, and where it's waiting too long. So let's talk about this for a second. If you find a hotspot within a certain module, you can now recompile that portion with your compiler, right? But the problem is, how do you find that hotspot? Now, that's what VTune does. If you look at your screen, you'll see it says 3.56 seconds for this algorithm 2, right? And everything else is like 1.4 or 0.0 seconds of CPU time. Well, obviously, you want to focus in on the areas that are taking the most CPU time. But for wasting time, it'll look at things like cache misses, right? So it shows you what portion of your code is responsible for this. It shows you locks by wait time, right? For CPU locks. This is all really good insight into figuring out where to go begin. I've talked to developers in quite a variety of situations, right? Driver folks, firmware guys, applications, all the way up to folks like in the medical industry, in the financial industry, oil and gas, right? Lots of people find different uses for VTune. The VTune is a pretty complex product. It gives you lots and lots of different options, right? But it's a very good way to determine where do you go focus your time on. And the third product is Inspector. And what Inspector does is it will help you increase the reliability and security by finding coding errors. And these are either memory and threading errors that can lead to parallelism problems. There's a class of errors you're probably familiar with, like deadlocks and race conditions, that are notorious for being very difficult to find, right? You can run a program 100 times, you'll never see the problem, right? And the 101st time you run it, of course, after you ship it out, that's when you find the problem. And Inspector can help you find these errors. And it's obviously much cheaper to find and fix these problems in the development phase than once the program's out in the field. Inspector always also supports this thing called heap growth analysis, right, which lets you see what's causing the heap to grow in a problematic region, right? So it shows you a list of memory allocations that are not freed up within a certain interval, right? Again, a very good memory checking tool, memory and threading checking tool. So step 1 was understand what's in your source code, right? And we have VTune, Advisor, and Inspector. Step 2 is, well, now what do you do about it? Well, we've got a couple libraries. The first one's Intel's math kernel library. I mentioned I've been in this group for about 3 years now, and this is really, the more I learn about MKL, it's just more astounding to me how much of Intel's best kept secret this is. MKL consists of thousands of highly optimized functions for science, engineering, and financial type apps. I've always been told you get what you pay for. In MKL's case, I think I'd make the argument that you can actually get more than what you pay for. MKL only costs, I think it's $499 for a license. There's no redistribution fees for this library, this set of libraries. And you'll see we've got linear algebra functions if you're like a computation fluid dynamics kind of person, right? We've got fast Fourier transforms, we've got vector math, RNG, we've got all kinds of RNG functions that financial companies, oil and gas companies, everybody finds quite useful. And on the little chart that you see, what you're seeing is S&P impact performance using MKL, right? And you'll see there's up to a 90% performance increase by using MKL. And there's no magic here, right? The reason we get 90% performance increase is we're using advanced vector extensions on the CPU. Right? So remember the feature we talked about on the CPU? Well, MKL takes advantage of those features, and they say, hey, let's go use it as much as possible. The library is also thread safe, so you can specify how many threads you want to use. Okay, next slide is IPP. IPP is our integrated performance primitives library, right, similar to MKL, but this is more for image, video, communication, signal processing, that sort of thing, right? The domains you can see are listed. And if you go to Intel's webpage, you can see a list of all the different functions that IPP supports. The chart that you see, I'm going to try and read this here. It's we're comparing Intel compiler to using IPP and then using IPP with AVX. Right, and you see cycles per element for this particular function goes down. So we use 31.84 cycles, and then we go down to 5.47. That's like a 6x increase, or a 5x increase. And again, no magic here. We're doing this by using AVX as well. Okay. The third one is our compilers, and Intel's compiler has we've got our C++ compiler and a Fortran compiler, and we're constantly measuring our performance against GCC or Visual Studio. And what you're seeing over here is we believe a compiler is usually quite a bit faster, like although your mileage may vary. So we've heard people say, hey, I've got 20% increase. Some people say I've got 2x the performance, and some people say, no, it's about the same, right? But if you find a hotspot within VTune, you can now recompile just that one portion with our compiler. Now, I realize for a lot of you who have got their development cycle already figured out, changing compilers can be quite a daunting task, right? But rather than using a new compiler for your entire code, you could just change the slow module that you find with VTune and recompile that particular portion. And you can continue using your current compiler on the rest of the code. Intel's compiler also features a feature called auto vectorizer, right? And I mentioned the SIMD widths on our CPUs are growing. By using these additional features, right, you'll see this big increase in performance because your compiler knows how to take advantage of the CPU features. So the compiler will automatically detect your code that has the potential to be vectorized, and it'll ask you as a user, hey, do you want to vectorize this? And then if you say yes, it'll say, okay, yes, we're going to go vectorize it. And this is where you typically see the performance increase. So that's step 2, right? Step 1, analyze your code. We're using Advisor, VTune, Inspector. Step 2 is use the low-hanging fruit, right? If you have a slow function, replace it with one that's an MKL or IPP. If you've got a hotspot right within your code, recompile that one portion with Intel's compiler. Right, step 3 is, well, now you want to actually change the way you write programs. And we've got a family of advanced parallel programming models over here. And they can be used on both multi-core and many-core processors. We start with Silk Plus. Silk is a company that Intel bought. It was an offshoot of MIT. Their idea was to make parallelism simple, which is a pretty daunting task. So what they did was they had 3 different keywords. So instead of using a for loop, for instance, you would use a Silk for loop, or you had Silk sync or Silk spawn. And of course, over time, it's grown, right? So you've got array notations, you've got quite a few. This is quite a rich product now. But Silk is a good way to if you're interested in changing the way you write code, right? Take a look at Silk, right? It's the premise was make this easy for people who don't want to do it, right? And then at some point, maybe you'll you'll embrace it. TBB, hopefully you're all familiar with TBB. TBB is the most widely used template library in the world now, and it's also open sourced, right? So you can either go to tbb.org or just type in Intel Threading Building Blocks in Google, and you'll see all kinds of links there. The domain-specific libraries we talked about IPP and MKL, right? Vast libraries, thousands of functions that are available to you at pretty low cost. Established standards, right? So Intel's got its own MPI. We'll cover that in a couple minutes. We also have OpenMP, Core Fortran, and we've made some very good strides in OpenCL. So we've got a free OpenCL SDK that's available on our website, and it continues to grow. And then we also have an area called research and development where we actually make new products or new features available. I shouldn't say products, they're more like concepts available for you to download. And sometimes there's promise, sometimes there's not. And this is Intel's way of determining whether there's enough interest and enough benefit out of the various things you see over here. And this list obviously changes. The great news is all of the stuff I've talked about, right? So VTune, Inspector, the analysis tools, the composite libraries, and the programming models are all common for both Xeon and Xeon Phi. So when and if you do start looking at Xeon Phi, right, there's no new programming language to learn. The paradigms are the same. Okay, so it's a lot to remember, and we've made it a bit easier for you. So everything we talked about, step 1, step 2, step 3, are all included in Parallel Studio XC. And this is our node-level parallelism. So this one has our C and C++ and Fortran compilers with OpenMP. It's got the libraries, MKL, IPP. It's got some of the programming models, Silk, TBB, et cetera. And it's also got analysis tools, right? And this product retails for, I believe, $29.99, or it's under $3,000. That's a retail price. And I was looking on TechXtend's website, and I think it's quite a bit less expensive there. Okay, I'm going to pause here for a second and share with you a customer success story. And this is actually both a good news and a bad news. So in this case, this is a large Wall Street firm, right, which looks at data coming in. And in this particular case, I believe this was a market feed application, a market data distribution application, sorry. And they've been trying for 2 years to thread it, and they could not succeed. And this, there were some really good engineers on this project. They came back to Intel and said, well, we believe that our application cannot be multi-threaded. We ended up getting some Intel engineers involved, right? And the company was also able to use some of Intel's online resources. And we found there was a false sharing error. Once we resolved the problem, we went from, you can see, 4.95 million messages per second to 22.5, right? We started scaling almost linearly as they added cores. The moral of the story is this stuff is not easy, right? So as much as I would love to say, hey, this, use Advisor and all the problems will be solved, it's really quite complicated. We're trying to give you powerful tools, right? But we're trying to solve a very difficult problem. If it was easy, you would have solved it by yourself. But the reason I had this slide up is to encourage you, right? Once you do download our tools, and if you're stuck, right, use Intel's online resources, right, and look at them for guidance or help, because it can really make the difference between, in this case, giving up or scaling quite well. Okay, so Parallel Studio XC, we talked about node-level parallelism, right? And now let's change gears a bit, and we'll talk about clusters. For those of you who have problems with which you scale across clusters, there's let's see here, this little chart on the bottom left of your screen is kind of shows you the race to exascale computing, right? And these guys are currently on track to go at 2x Moore's law. Now, they don't have any magic silicon. They don't have any magic factories that are building these chips twice as fast as we are. The reason they're achieving this, as you can, if for those of you who've guessed, is they're adding cores at twice the speed, right? And that's how they're able to go to 2x Moore's law. But there's problems with that, right? In order to do that, your software development solution must have really good performance. It must be able to scale forward and be very efficient. So if you're developing highly parallel applications that require cluster-level computations, right, and these are typically customers who do oil and gas exploration, advanced physics simulations, life science, medical, that sort of thing, right, we've got Cluster Studio XE. It includes everything in Parallel Studio XE plus Intel's MPI library. It includes threading and some MPI-specific insight tools. It includes a product called Intel Trace Analyzer and Collector. The key over here is even though, like alternative technology like GPU, you would have to rewrite your program, or some apps can be written because they're too large or complex. What Cluster Studio XE does is allows you to take what you've done on the node and then scale it across multiple computers. So Intel's MPI library, this provides you with a set of communications that allows you to divide up your problem amongst multiple CPUs or servers, right, within a cluster. MPI, of course, is a standard. So we have some unique features in our library. By providing faster communications, we're able to provide much lower latency. And we're also able to, we're interconnect independent, so you can select the interconnect fabric, for example, if you're using gigabit Ethernet or InfiniBand at runtime, right? So I believe other MPI libraries typically require recompile. And we also have this program called Intel Cluster Ready, which the idea is to make life easier for your customers. So if you have a system that says Intel Cluster Ready, it's essentially a certification program which states any of the tools or software that you buy will be ready to run in a cluster just out of the box. We currently scale up to 120,000 processes, which is, it's a pretty big cluster. And I'm told by the engineers there's no limit to the number of processes. We just haven't been able to test it past 120,000. Another product that we have under Cluster Studio XE is a product called ITAC, Intel Trace Analyzer and Collector. And what you're seeing on your screen is this is our built-in MPI communications analyzer and correctness checker. So what you're seeing on the screen is blue and red bars, and the blue is time spent on computation. Red is time spent on communication. And by digging into this time, you can determine, hey, do I have too big of a problem? Do I need to change my problem size, or am I spending too much time on the communication part? Right? It gives you insight where, I've seen people who do MPI for years play with this tool, and they've just got a smile on their face. They're like, wow, I just have insight into my application that I never had before. We can scale up to, I believe, 6,000 MPI processes in the latest release, and within this tool, you can group MPI communication based on nodes, topology, et cetera, right? Very good insight into your MPI. Okay, so a lot to remember there. And Cluster Studio XE includes everything in Parallel Studio XE, plus the MPI library and the ITAC tool, right? So again, right, if you have node-level parallelism, choose Parallel Studio XE. But if you have a cluster MPI, if you're using MPI, you may want to consider Cluster Studio XE. This product is a little bit more expensive, and I will find the price before if anybody's interested, I can tell you the price. Okay, a quick feature comparison, right? I'm not going to go over this, but just kind of show you, these tools are quite rich. I covered probably maybe 10% of what's in there, right? There's hundreds and hundreds of features in each of the products. So we've got compilers, libraries, common across both of them. Intel Inspector XE is common across both of them. VTune is as well, right? The difference is when you get a Cluster Studio XE, you add Intel's MPI library and ITAC, the Trace Analyzer and Collector. All right, so I'm going to pause over here for a second and answer some questions. Let's see here. One question, when you say 61 cores and 4 threads per core, are these threads akin to hyperthreading? So yes, so Xeon Phi supports 61 cores, and it is 4 threads per core, but hyperthreading is more of a virtual, right? And this is real, right? So Xeon Phi does not support hyperthreading, to my knowledge. It's 244 actual threads. The 61 cores, one of the cores is typically reserved for the processor itself. It's only 60 cores that are available, right? So think of it as 240 cores available to you, 240 threads available to you. And is there another question in here? what version of Intel Fortran compiler should one use for running an application on the Xeon Phi processors? You know, I would always recommend the latest. In November, we shipped a product called Intel Cluster Studio XE 2013, and I believe the compiler version is 13.0. We have an update coming out. It may already be out, update 1, but with 13.0, you're safe. You've got a pretty dramatic bump in performance over the last couple of generations. So if you're using a like version 9 or 10, which we often find people using a couple-year-old compiler, I would definitely recommend try 13.0. You can download an eval from Intel's website for free, and you can give it a try. But 13.0 or later for Xeon Phi. 13.0 was the first compiler version to support Xeon Phi. Okay, so the side on your screen talks about Xeon Phi. And Xeon Phi is called a game changer for HPC performance programmability. And the reason is what's on your right-hand side of your screen, right? So for those of you who are already used to Xeon, right, you're already familiar with the languages, the compilers, developer tools, libraries, right, the techniques you use to code and optimize, right, the entire ecosystem. Well, the great news is everything on Xeon is common with Xeon Phi. The terrible news is everything on Xeon is common with Xeon Phi. I'm going to give you a minute to think about that. Why is that bad news? Well, I'll explain why, right? People, with Xeon, you've got 4 cores, 8 cores. With Xeon Phi, you have 60 cores. So people come to us and say, wow, well, it has 60 cores. It must be much, much faster. And then they go off and use our tools, and they make their code run on Xeon Phi, and sure enough, it runs, but they don't see the performance bump, right? Xeon Phi is really meant for embarrassingly parallel workloads, right? It's not meant for every single application. In fact, I would think, I'd heard somewhere people say that's maybe like 1 out of 4 applications are well suited for Xeon Phi. But because it's straightforward to take Xeon code run on Xeon Phi, right? And there may be the illusion that, hey, because it's got so many more cores, it's going to be much faster. Remember, a Xeon Phi core is much, much smaller than a Xeon core, right? These are Pentium class cores, whereas a Xeon core is a pretty beefy core. The quote at the bottom, unparalleled productivity. Most of the software simply does not run on a GPU, right? That came from one of our customers who are part of the 100 beta testing, right? So we've got lots of results and lots of data on Xeon Phi. For those of you interested in hardware, there's quite a few resellers selling 1U systems on Xeon Phi, which include up to 3 Xeon Phi cards, right? So we're looking at, let's see, 60 times 380, up to 200 cores per 1U in a rack, right? So we're looking at 4,000 plus cores per rack, right? So, boy, core counts really start to become, taking advantage of multiple cores becomes very, very important with Xeon Phi. So Xeon Phi is available in 2 SKUs. There's a 5,000 and a 3,000. The 5,000 has 61 cores, 244 threads, 8 gig GDDR5, total aggregate bandwidth of about up to 320 gigabytes per second. This coprocessor is capable of up to 1 teraflop of double precision. I'll give you guys a funny example here. We did a seminar in South America a few weeks ago, and we had a system that was shipped from the U.S., and the system basically fit on an office chair. We put an office chair, and we put it in the elevator, and we were presenting a couple floors up. And that system was capable of 2.3 teraflops per second, right? And the people in the audience were just floored that a system that I picked up and put an office chair and wheeled up in the elevator was capable of 2.3 teraflops per second. It had 2 Xeon Phis, and I think it had 2 socket Xeons in there as well. Programmability, C++ Fortran, so Parallel Studio XE, Cluster Studio XE, version 2013, the latest ones, both support Xeon Phi. And then for applications, I'm going to go to the next foil. Here's kind of a list of the applications we're seeing that are well suited for this, right? So molecular dynamics, we're seeing 2.5x increase. And this increase is what I would characterize as a very fair increase. It's basically taking optimized code in Xeon and then comparing it to optimized code in Xeon Phi, right? We're not playing any tricks where we're taking a single core, single thread, unoptimized code on Xeon and comparing it to like fully optimized code on Xeon Phi. Acceleraware 2.05x. If you're using Monte Carlo, Black-Scholes, right, for those of you guys in the any sort of data mining, statistical analysis, right, industries, right? This is huge promise, 10.75, 8.9x, right? Huge increase over here. So if you're in these industries, I would definitely recommend trying to get a hold of the Xeon Phi and take a look at it, of what it can do for your application. Seismic imaging, solvers, ray tracing, right? So there's some promise over here, right? But these are very specific applications. And the best way, if you're interested in learning more, is I'm going to give you guys a list of white papers, especially one that I'd encourage you to read, and download that and take a look at, try and determine if your application is well suited for Xeon Phi. Okay, so who benefits from parallelism? People often ask us, hey, I'm in this industry. Parallelism sounds like, your tool sounds like it's great for like a Wall Street bank who's extremely interested in the latest and greatest performance, right? Or if you're like an oil company who's doing, who's mapping the ocean floor. But it turns out that, we have customers from all over the place. We have thousands upon thousands of customers. And we see people in 3D modeling, bioinformatics, right? Lots and lots of people in data mining, statistical analysis, lots of computational fluid dynamics type folks, simulation tools, medical. We did this great case study with GE Medical where we helped speed up colonoscopies, not something which, I think not something you want to talk about publicly always, right? But certainly if you can speed it up, great. We just did a very interesting children's cancer case study with Dell where we were able to take a children's cancer, which typically took the hospitals, I think it's 11 days to map the genome. This particular cancer requires them to map the genome and give them custom medication. And our hope was to bring it down to 5 days, right? And by making it, by reducing the time in half, we were hoping to, obviously help, save children's lives. And I'm just thrilled to say that we brought it down to 1 hour, right? Went from 13 days to 1 hour. And we did that by both throwing more processing power at it, right? We used a cluster, right, for the problem. And then we also used Intel tools, Intel compiler, and inspector, right? But these are the kinds of things where, when we talk to customers, a 10-15% increase in performance is pretty normal, right? If you don't see that, it's actually quite rare not to see that. But we often find people with 10x, 40x, 100x performance increases by using some of these tools. So I hope your company is in one of these little icons, and I hope you will also see some increase in performance. Okay, ROI. For the guys in the room who have to convince their managers to buy this tool, or for the business decision makers, right? Yes, these tools are expensive, right? Parallels 3XC is $2,300. I misspoke earlier, $2,299. So we've done a ROI analysis, as you would expect Intel to do, and if the performance increase itself doesn't pay for it, what we typically see is we're looking at about a 6.2 weeks developer savings, and there's a big, huge white paper behind this, if you want to read it, right? So we're looking at about a 2-week payback, right? So if you get, frankly, as a developer, if you save a week or more of time by using one of our tools, Inspector, for instance, right? You can't find a race condition or a deadlock. If you use our tools, you can find this within a day or two, right? You've just more than made up the money that you spend on the tool. So although we charge for our tools, we're not in this business primarily to profit from the tools, right? It's really about enabling you to get better performance, right? And but yes, we do charge a little bit for the tools. And by the way, there's no per core charge, there's no per MIPS charge, right? It's just licensed either per seat or as a floating user. And TechXtend can give you all kinds of details on that. Okay, some resources available to you. I try to make a list of some reseller links, some software links, just learning about software, some case studies, right, in case you're interested in a particular vertical. And then, of course, product briefs, web pages for each of the products we talked about, and some white papers. And once I made the list, I'm like, wow, that's a lot to read. So what we did was we highlighted a couple where I'd recommend you start. So for Xeon Phi, there's a developer portal that's listed over here. It's software and telecom /Mike developer. And that's a great place to start for Xeon Phi, right? It's got all kinds of resources, got code samples, really a good place for you to go in and look at, determine whether the application is well suited for Xeon Phi. and it's run by experts. So there's lots of other engineers in these communities and these forums. Another white paper that I'd recommend you read, is this white paper called Programming Overview for Intel Xeon and Xeon Phi processors. And that's also very good reading, right, where it'll list out the characteristics you should be looking for within an application, right, to determine whether you'll be a good candidate for it. So, this list, contact tech extend for this list, right, or, again, if you just type in Xeon Phi software portal on Google, you should be able to find the main website. Okay, so, gosh, we went through that fast. Let's open up some questions now. Natalie, do we have questions?
It doesn't seem like any have come in. Let's give it another minute or so.
Okay, here we go. So here's
a
question
for
we
okay.
have an OpenMP version of our software which scales pretty well on 16 cores, about 75% efficiency. Well, that's scaling since Xeon Phi. Again, it depends on the application, right? If it's an embarrassingly parallel application, which means it does really well across multiple cores, then yes, it should. But it's going to depend on, get a Xeon Phi, right, and try it. Or else, once you read those white papers, you should be able to have a better idea. But it really depends on what the application itself is doing. Certain workloads are very well suited for it, others aren't.
Okay, and then it looks like we had, as a single developer, what's the best way to test under this new hardware, i.e. cloud services like Amazon, EC2 support?
I don't know if I completely understand the question.
It's in the chat.
Okay.
From David.
You mean, okay, here we go. What's a single developer? What's the best way to test some of these new hardware? Well, we do have a CRT that's Intel has a data center which we built in DuPont. I don't know if it's available to anybody. It's certainly available to larger customers. And this data center, I believe, is like 250 teraflops. They've got 200 some Xeon Phis in there, right? And what you're able to do is, if you're a university or an education, you can set up an account with them, and then if you want to teach a class using that cluster, they reserve a part of that cluster for you to go do simulations on it. That's one option, right? But David, you can feel free to send me an email. There's quite a few Ashish Guptas at Intel. Mine is ashish.gupta@intel.com. I'm the original, but and I can try and find a different way for you to do it.
Okay. How many multiple applications scale across in Windows with Phi processor?
Well, Phi at the moment supports Linux. So, but there's a Windows version. Windows support will be coming out, I believe, later this year. So at the moment, it's really about Linux, right? And the reason is most people who use Phi are in the data center, HPC, like the high-end technical enterprise computing space. And we rarely talk to people who use Windows with MPI, right? It's really about Linux.
Okay. If you build an app using these tools, what happens to the customer who does not have an Intel chip in his computer?
It's a really good question. Compilers, libraries are typically will take advantage of whatever CPU you've got, x86 CPUs, right? But this VTune, for example, is the biggest difference. So I talked about PMU. Remember the performance monitoring unit, that little black box in your CPU? Well, the way we do it is different from other companies. So what VTune would do is they would look at software counters, but not the hardware counters, right? So VTune would still work, right? But you don't get the deep insight that you do by looking at Intel's PMU because it doesn't exist with a non-Intel CPU. But it does work across Atom, Xeon, and Core, right? So it's got quite a few different options.
Okay, and then does Intel plan to support Fortran on Mac OS X?
One moment. Okay, yes, we support this today.
Okay, and looks like that was it for the questions. Not sure while we're getting through to some, if any more are coming in. We'll give it a minute or so. In the meantime, thank you everybody for attending. You can contact us at info@techextend.com or visit us on our website at www.techextend.com/Intel. Also, you'll be able to find a recording of this webinar there later on this afternoon with the slides for those of you who would like to review it again. And for Canada, we could be found at www.techextend.com/Intel again. And thank you very much, Ashish, for the presentation. And if anybody has any questions, please feel free to email us with them. And again, the recording will be available later on. Thank you, everybody, for attending.
Great. Thank you for your time, everyone.